Last time we ended up implementing a HTTP client on the ESP32. We could call out to regular IP and also HTTPS endpoints with DNS and HTTP certificates. We didn't do actually verifying the certificates, but that's for another day. Today I would like to do what we did before in the IDF framework, is to host the HTTP server by listening to a port. Before we did that using the ESP IDF framework, so basically those are implemented in C, and you can, there are Rust bindings for that, and that's pretty easy to use. There were some downsides though. One thing I don't like that much is the fact that it's blocking, and you have to, in order to do multiple things in parallel, you have to somehow balance it out using the RTOS tasks, and I didn't really get it to be smooth, especially if the frequency was high. So when I was running my stepper motor, I could hear in the stepper motor wherever I would send a HTTP request, it would just hold for a little bit, and that's not good enough for me. So I thought let's try to see if there's something on the async side, so something that runs on top of Embassy as well, that isn't blocking at all, that only activates whenever there is something on the network happening and just dealing with that little bit of data at a time. So you can hopefully keep going on the on any other tasks. So there wasn't much, but pretty recently, this is from 2 months ago, but I only saw it like maybe 3 weeks ago or something like that, and that's picoserve, and that's Embassy based framework that's inspired by Axum. And Axum, I don't know if you're familiar with it, but that's a very popular web framework for Rust. And that works actually reasonably well. It is kind of rough. It's very early days. There's also not an awful lot of committers. There are 2 people, I think. Yeah, and since I've been looking at it, it's been pretty much dead, so I'm not sure if it will continue to be maintained, but it is a nice proof of concept, so I want to roll with it for now. However, let me get back to the browser, this one. It is intended for the Raspberry Pi Pico, so that's a different chipset, so we'll need to see if it all works. So let's go. We already have Embassy, so let's see where we end up. Let's stash any changes. Branch, no, let's do this, let's see. On the main, that seems okay. Okay, so let's start by let's start by doing something else, which I just found out, which is just easier. There's a macro here that's inline. This is from the example, I think, from Embassy. And there is a nicer way to do that, and that's in the static cell, cargo, and there's a macro in there. It is behind the nightly feature flag, so I'm going to add that flag now. I already had static cell, and that introduces a nicer macro. So let's do that. We remove this one, and then we clean up after it. So here there's a singleton, and that has now the make static macro, and this one is make static as well. Oh, what happened here? Make static. That cleans up that, and here we kind of did a manual version of that. So let's remove, this one. This is the creating a static, and we just basically do make static, and we do executor new. Any problems? That has That's interesting. I think that started to happen at some point due to that macro, that it complains about the return type. So it says it returns a void. Instead, it should never exit at all. As far as I can tell, it doesn't, because this thing never ends. But if I remove the semicolon, it seems to calm down. So that's that out of the way. So we can clean this one up. What's next? Okay, let's add picoserve. So you can run it with Tokyo if you have standard. We don't, so we don't. But we're gonna run it on top of Embassy. Now let's have a look at one of the examples, because the documentation is pretty limited. But yeah, the Rust way seems to be to just supply automatically compiled examples, which is not bad. It's an annoying thing. It's at least something that works. So if we look at this, it looks actually kind of familiar. There are a lot of things. The Embassy configuration is a little bit different due to the different chipset. Logging configuration is a little bit different. But this net task, for example, is identical. Well, pretty much. The type is slightly different. There seems to be a timer. That picoserve has a timer trait that needs to be implemented, in this case for embedded. So it looks like this one we can just copy paste wholesale. I think it will be totally identical. Here we go. It complains that we need to add a flag to allow async traits because it's not stable yet. But if we feared unstable things, we wouldn't be doing embedded Rust, right? So now this one is happy. Move on. It uses a notion of app state. I'm not going to do that this time. But that's basically that gets injected into any method that deals with requests. So that's I think if you're really interested in it and you want to get into this, it might make sense to watch Exum tutorial or two. There are lots of those out there, and it's interesting in its own right, because it's a little bit different than the most net web frameworks. I mean, you kind of have to, because Rust can be finicky with ownership, so you need to have a decent idea on how to deal with that. But let's have a further look. So this I'm going to gloss over a little bit to pass around the state. I'm going to try to do it without any state for this episode. Here seems to be a type alias. and web pool task size. And I think that's how many concurrent web tasks you can have, because it's all intended to run without allocation. So then you need to have fixed sizes for all of those things. But on the plus side, you know you're not going to run out of memory. So that there is that. There seems to be, I never saw this one before, a pool size parameter on a task macro. So if I understand correctly, you can say how many times this can run simultaneously, or that it will run. I'm not entirely sure about that one. For now, I think it's good enough to stick with a single one. So that kind of keeps this simple. For the rest, it looks kind of familiar. I think this is just a counter, not very important. Stack is pretty much our stack, just with a different driver. This is the route we created before. Well, we pass it in, I think we'll create it later. Configuration, basic, and the app state, which we're not really going to use right now. Also, we see so this does stuff. We'll get into that later. I'm not 100% sure how it exactly works. Some things kind of look weird to me, that this TCP socket gets created in this loop. Like, I would kind of conceptually think that there is a socket which is persistent, and you just accept, and then you get from a server socket, and then you get a socket. But it does seem to work, so hopefully it gets clarified a little bit. So it listens to a port. That seems straightforward. Log something, get the read and the write channels, I guess. What does it? Oh my! Oh, this, of course, it's a browser. It splits this, and then it runs the serve with state. There's also one without state, and deals with whatever happens. So let's copy this one into our careful. Let's take all of these. Into our little thingy. All right. So, what's wrong here? It's unconstrained, so probably is because we don't actually use it. I'm not gonna use a pool size right now. I'm just gonna consider it a normal task, so we can remove this one. This stack is different. Let's keep it the same as one of the other methods, so we just use this one. I don't really want to pass this one in. I'll create it inside. This is fine, and I also don't need state for now. Just keeping it simple. And now, let's kill this one as well. So we replace this one with serve. So then we remove the state. Then where do we end up? First of all, we don't have the app right now, so we need to make that, and that goes something like this. So let app is route router, new, I think, and then add a route, if I am not mistaken. Let's see if we need to import things. Yeah. Import router. And then we can add routes. And then we can do a route. Let's call it, I'll just do the route. And then here we can add a handler. We can add a closure in here. Or what's I think usually the nicer thing to do is to create a function, an async function that handles that. So let's make async function, let's say get root or something like that. Root, and that returns an impl response. Now into response. This one. Oh. And then we can do anything that implements the right things. We can start with just returning a hello world. And we can address this one by using get. And we do get root. Not like this, I think. Let's find it in the imports. Yes. So we call the get routing method, and we pass in the function pointer. So this is not a function invocation, so there shouldn't be any brackets here, because that wouldn't make sense, because then it gets called once, right? So this needs to be borrowed. And now it gets interesting, because there seem to be some issues, and especially around this one. That turned out, after a lot of fooling around, to be due to mismatched versions of the Embassy version. If you look in this cargo, you see that, for example, the Embassy net, well, basically all the Embassy, they point to a revision in on a Git dependency, and not a create published one. So that's something we'll need to deal with, because they are quite different. I hope soon there will be a release of most of them actually. The versioning scheme with Rust can be a little bit finicky, because especially in the end, a lot of people, what they tend to do is just you take one version of all those Embassy things and you point them to all of them to the same one, and all of those subcrates, they have their own version, but in this case nobody cares. If you follow like this, you at least know you don't really have the semantic versioning part, but you know they'll work together at least. So let's take it as we find it. So the Embassy net is the one that's the problem. So here we used the published one, 010. Hopefully, maybe by the time you see it, all this has been fixed and it's not a problem anymore. There are some features that are missing: the DHCP, the DNS, the log. Actually quite a bit more than I thought. I should have done it the other way around. we have nightly, we have TCP, I suppose, yeah. Let's, oh, and also the medium IP. Let's not remove anything and keep the other components happy. So we remove this one for now, and then see this one. Let's see what his problem is. I'm not sure what's happening here. Oh, yeah, I didn't spot it. So the unstable trade feature seems to have disappeared in the meantime. So be it. Remove it. And now it seems to actually do something. Okay. So let's see where that leaves us. So these errors seem to have cleared up. We got to this interesting beast. And that has to do with the ESP Wi-Fi. So that's the crate of the ESP that supports that supports Embassy. That's out of sync because that relies on the one we were using. So as those Embassy crates at the time of recording aren't released, I'm pretty sure they don't want to depend on a Git commit like picoserve does. So what I did, I ended up making a fork of it for the time being, so I can get this to work. And I have no intention of making it a real fork. But just for the time being, I just fixed what I did, just the things that made this work, and to show what I actually changed, that was basically pointing just like I mentioned. We're pointing now to the Git dependencies rather than the deployed ones. And I used just all the same version of Embassy for all the Embassy things. This was just some... And this was one of the problems that was in there, that apparently a method name has changed. Well, it's a slightly different pattern, so I guess it has to do with evolvement of traits. And I think there wasn't really here an awful lot. Yeah, there was a little bit of a difference with the macros. Yeah, come to think of it, I need to include these ones as well. So let's see, right here in the executor. Let's put it separately for a moment. And these two features need to be added to the executor. And I'll take the same revision then as the net one. It's all a bit sketchy. I mean, there is officially no guarantee at all that this will work. But yeah, sometimes you gotta do what you gotta do. Let's see. This is still failing somehow. That might be due to the driver. I think so. Let me check. So it uses this network. I kind of expected this one to clean up. Let me check in my notes what that looks like. So I updated Embassy net with all those thingies. I think I also need the Embassy net driver. Take the same Git repository and the same revision, just the features don't exist. That's my theory right now. Oh yeah. And no, that's dumb. Yeah, I don't think that mattered. I still need to point to my forked version, right? I had a forked version of the Embassy, and let's this one. Let's get a commit hash. Oh, it's a big one. Does not matter. Go back to main. Now this has cleared up. So what remains now is to actually use our task, because we created what's its name? Is it this one? Yeah, the web task, and we're not invoking it at all now. So let's do that in our spawner. Oh. I'm not quite sure why the autocomplete is acting up so much. And so that web stack wanted to have, I don't really want that ID. A config, let's see, I'll just remove it from these places. I might have to re-add it later, but so be it. So I don't need the ID anymore. What else? This one is now, yeah, so now this one is acting up because the dependencies are out of whack. We'll get to that later. I'll clean that up in a bit as well. So that stack needed some more things. That needed a configuration, right? Yeah, that configuration was probably in the, let's see in the example. Config. this one. So basically you create a static thingy and you set the, I guess, the connect and request read timeouts, something like that. I have no real way of knowing exactly how it works, but let's roll with it. And we add the config. And most lights are green now. There is something else we need to do. That's because as we roll into our web task, it will just all start them at the same time, right? So we need to do the same thing we did for the HTTP client, is that we need to wait until the link is up, because otherwise it will just crash and burn before it had any time to try anything at all. So that I'm not going to fix this thing right now. I'm pretty sure we can make it work, but actually on the Embassy side, today I saw there were some releases also, I think, related to all this. So I don't want to really put a lot of time in, while it might resolve itself in the coming days or weeks. So don't want to sink in another day, because actually I spend a lot of time on this one. So let's remove this one. So there, not completed this one, that's why it was acting up. So some warnings, but for the rest it seems to be alright. So let's see what this does. I haven't really installed my desk cam, but there is very little to see in any case. I have my my ESP thingy. Oh. It's still blinking right from the last time. So let's do some cable travel. Let's do the thing. Let's do ESP flash. So I call the ESP flash command release import, otherwise it doesn't work at all, and I can go straight into the monitor. Use this port. Let's wait. It's getting a little bit bigger now again, so we can play some smooth jazz while it uploads. Alright, so let's start the Wi-Fi. Waiting for the IP. It got one and it says it's listening. So let's see if it actually worked. So let's do a little curl, and we just were listening to the root, I think. Hello world. And if I carefully show it to you, AI camera. So it's still blinking, right? And just curling it doesn't influence the blinking, which is too early to tell if it's really okay, but it's nice to see it work. And in the end, like, the end solution is, I think, pretty straightforward. I forgot to unwrap this one. But it's all right, and I think all the methods you can use to extract path data, so that you can parameterize what you want to call based on the path, or query parameters, or cookies, or all those things. I'm not sure what is implemented, but it's already a lot better than the alternatives we had on the ESP IDF. I had to manually parse query parameters, which for simple things is doable, but there are a lot of edge cases you don't really want to deal with. And there was an example on the Embassy, in the Embassy repo, that would help you deal with this. But that was manually parsing HTTP. So I think that was, let me find the real one. Well, it doesn't actually matter. But there was an example, and Embassy DHCP, I think. And that did the, no, this one, like here, wait, same like we did, wait for the IP to appear, and then we, oh no, this was an HTTP client, but the same story, right? You do a TCP connection, you say get HTTP stuff, you write the things, you read the things. I wonder, oh, that was in the LED demo that I linked in a few episodes ago. But that was the same thing, right? Manually doing HTTP, which I'm really not keen on. So I think this is a decent path forward. So yeah, I'll leave it at that. Yeah, tell me what you liked, what you like to see. I have a lot of thanks for all the suggestions. I ordered some hardware to test some things, but there are honestly some things like getting a camera module to work on the ESP32 in Rust. I really can't find a lot, so I will have a look if I can get it out there. But yeah, it's nice to see that right now, if I look at this piece of code, it's quite similar as doing one in a real operating system with Exum or something like that. And I think that's really exciting, that you can make a real sort of scalable API without having to do all kind of crazy hacks. Well, we had to do some, but they are bound to get better soon. So yeah, I will do some more ESP32. I will be away for a week, so maybe a bit less for the moment. And yeah, we'll see where we end up. See you next time. Bye.